Hello, welcome to another lesson in geometry. Today we're covering section 2.4, deductive reasoning. So inductive reasoning was looking for patterns and then trying to draw a conclusion from patterns we see. Deductive reasoning is a little bit different, okay? All right, so vocabulary first, write the converse of each conditional statement. So if I am thirsty, then I drink water. So the converse is to flip around the hypothesis and conclusion. So if I drink water, then, water, then I am thirsty. Okay, and our second one, if the car outside is wet, then it rained. If it rained, comma, then the car outside is wet. Okay, all right, vocabulary builder, deduce. So we pronounce it deduce or deduce. Okay, related words, deductive, that's the adjective, or deduction, that's the noun. So a definition is to deduce is to use known facts to reach a conclusion. So we don't look at patterns, we look at facts we already know, okay? Your main idea is when you use general principles and facts to come to the conclusion, you deduce the conclusion. So your friend is wearing red today, he wears red only when there is home game. Use these facts to deduce that there's a home game today, okay? So he's wearing red, he only wears red on a home game, so therefore he must have a home game today, okay? We could take these known facts, your friend is wearing red today, and he wears red only if there's a home game, and we could put those two blue facts together. He only wears red if it's a home game, and he's wearing red today. That, it must be a home game, okay? All right, complete each statement with a word from the list. Use each word only once. You use blank reasoning to draw a conclusion based on facts. So this is deductive reasoning. So we take the facts that we know and we can draw a conclusion. No longer we're looking for patterns and hoping we can't find a counterexample. We take some facts and we should be able to tell a conclusion directly. Okay. The conclusion of your reasoning is a deduction. That's the noun. This is what we end up with at the end is a deduction. And the teacher will not deduce that a dog ate your homework. So I am not going to believe that fact about you. Not likely to go on to believe your facts that your dog ate your homework. Okay. All right, let's flip the page. Okay, on our second page, we have two very important properties, the law of detachment and the law of syllogism. Okay, and we're going to go through what those mean, and then we'll do some examples. And this will help us with our deductive reasoning because it'll help us take two true facts and put it together to get a conclusion. Okay. All right, so first one, the law of detachment. If the hypothesis of a true conditional is true, then the conclusion is true. So for instance, this, we have a true conditional. Some P implies Q, and that's a true statement. And we also have some example of P, then we can deduce that Q is also true. So if the conditional is true, and we have an example of the hypothesis that's true, then we can bet that the conclusion is also true. Okay? So use the law of detachment. What can you conclude from the given information? So our first one is a conditional statement. If there is lightning, then it is not safe to be outside. And then Maria sees lightning from the soccer field. Okay? So we have a true conditional. If there's lightning, it's not safe to be outside. You should really be under cover. And I don't mean under a tree. Marla sees lightning from the soccer field. So this is an example of the hypothesis from our true conditional. So what should we be able to deduce? So underline the hypothesis of the conditional and circle the conclusion. So here is the hypothesis. If there is lightning, and the conclusion is it is not safe to be out in the open. Now, underline the correct word or phrase to complete each sentence. Maria sees lightning from the soccer field fits or does not fit the hypothesis of the conclusion. And this fits. There's lightning. She can see lightning. Okay, so that does fit the hypothesis. Therefore, it is not safe to be on the soccer field. Okay, because we're out in the open on a soccer field. We're on a flat surface, so we are the lightning rod. Okay, so but given this true conditional, we see an example of the hypothesis, we can conclude that it is not safe from the conclusion of our conditional statement. Okay. All right, so that's the law of detachment. And always kind of remember it because P implies Q, and then I have the P. Okay, so this is the stuff given to me, and I really would like that Q, and that Q somehow got detached in that second statement. So then this is what we can deduce. Okay, so we're given the true conditional, we're given an example of the hypothesis, and we would like to deduce the conclusion. Okay, that's what the law of detachment says. All right. Now, the law of syllogism is a little bit different. You can state a conclusion from two conditional statements when the conclusion of one statement is the hypothesis of the other. So if P implies Q is true, and Q implies R is true, then I can skip over the Q part and just say P makes R true. Okay, so what's really saying is P implies Q, Q implies R, cut out the middleman, and you can see P implies R. Okay, so up here is our given, and down here is what we could deduce. And that's just to cut out the middle guy. Okay, so let's complete each conclusion. If it is July, then you are on summer vacation. If you are on summer vacation, then you work in a smoothie shop. Okay, so notice that the conclusion from our first true conditional statement is the hypothesis of our second conditional statement. That means I can skip over these and go from if it's July, then you work in the smoothie shop. Okay, so when one conditional statement is the conclusion, and that conclusion is the hypothesis of the other conditional statement, then you may skip over that part and go from the hypothesis of the first one to the conclusion of the second one. All right. So if a figure is a rhombus, then it has four sides. And if a figure has four sides, it is quadrilateral. So notice the conclusion from the first true statement is exactly the same as the hypothesis of the second statement. So I can skip over it and go the hypothesis from the first one, figure is a rhombus, then the conclusion of the second one, it is a quadrilateral. Notice in both of these cases, law of detachment and law of syllogism, we're not looking for patterns. We have some known facts, and we're going to deduce something from those known facts. And the two ways we're going to do it is using the properties law of syllogism and the property of law of detachment. Okay, so the way to recognize it, the law of syllogism, you're going to have two conditional statements in your given, and in the law of detachment, you're going to have only one. And the law of syllogism is going to be a whole new conditional statement, and in the law of detachment, it's just the conclusion from the first one. Okay. All right. Using the law of syllogism. What can you conclude from the given information, and what is your reasoning? So if a number ends in 0, then it is divisible by 10. And if a number is divisible by 10, then it is divisible by 5. So identify the P, Q, and R. So the P is this part. If a number ends in 0, okay, then it is divisible by 10. So that's our Q. Here's P. And this is Q. And I know that that second one is Q because my other conditional has that as its hypothesis. Okay. Now, when you're doing your homework or classwork next time, you're going to see these two statements mixed up. So you got to find the one that has the conclusion and the hypothesis the same. And then you know that the first statement should be the one with the conclusion that's the same as the hypothesis of the second statement. So a lot of words in there. Okay. All right, so a number is divisible by, let's see, a number is divisible by is going to be my Q. We already said that. And then the conclusion of that second statement is our R. A number is divisible by, oh, we were supposed to fill that in. So P is a number ends in 0. Q is a number is divisible by 10. And R is a number divisible by 5. Okay? All right, so if a number ends in 0, it is divisible by 10, and if it's divisible by 10, it is divisible by 5 also. Okay. All right, let's flip it over. Decide which parts of the information is true or false. Write T or for true or false. So P implies Q. That's a true statement. Okay, so we have to flip back. I don't like this, but we have this. A number ends in 0, then it's divisible by 10. That's a true statement. And then we have a number is divisible by 10. It's also divisible by 5. That's also a true statement. And then in conclusion, if a number ends in 0, it's divisible by 5 would be a true statement also. Circle the parts of the law of syllogism you will write. Okay, so P implies Q, and Q implies R. This is our given, and we could deduce P implies R. So this is the part that we would write. Okay, so now write your conclusion. So if a number ends in 0, then the number is divisible by 5. So we're skipping over the number is divisible by 10 part in the middle. So this is the part we would write ourselves because this is what we can deduce. Given this information, a number ends in 0, a number is divisible by 10, and a number divisible by 10 is divisible by 5. We can put them together to deduce if a number ends in 0, it's divisible by 5. Okay? All right. Problem 3, using the laws of syllogism and detachment. So we're going to do two things together. What can you conclude from the given information, and what is your reasoning? If a river is more than 5,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it is the longest river in the world. And then the Nile is 4,132 miles long. Oh, let's see. So let's see. We have a river is more than 4,000 miles long and is longer than the Amazon. So this is one hypothesis we have, and that's a conclusion to go with it. And then we have a river is longer than the Amazon. Oh, these two match. So this blue one and this blue one match. So that's the conclusion from one and the hypothesis to the new one. And then we end up with it is the longest river in the world. Okay. And then we are given the Nile is 4,132 meters long. Well, that's longer than 4,000, right? So we should be able to conclude that it's the longest river in the world. So let's check it out. So P in this case is the green one that I wrote up above. That's the river is more than 4 miles long, 4,000 miles long. Okay. The Q is, it is longer than the Amazon. And then the R is, it's the longest river in the world. Okay. Use the law of syllogism to complete this new conditional. So we can put these two together to write a new conditional. We're going to start with this river is more than 4,000 miles long. It is the longest river in the world. So if a river is more than 4,000 miles long, and we're going to conclude with, then it is the longest river in the world. It is the longest river in world. Okay? And then we're going to use the law of detachment to take this conditional right here and apply it with this hypothesis, the Nile that makes our conditional statement true. So this Nile is 4,132 meter long. So this has been detached from this 4,000 miles long, more than 4,000 miles long. So we can conclude that since our river makes our hypothesis true, then the conclusion must also be true. So the Nile is the longest river in the world. Okay, so this puts both of our two laws together. Okay, first we use the law of syllogism to write a new conditional statement combining two of our things that we were given. So we deduced a new conditional statement. And then given our new conditional statement and a hypothesis that made our conditional statement true, we were able to deduce the conclusion of our new conditional statement. Okay, whew, that's a lot of stuff there. All right, lesson check. So once again, pause the video, try it yourself, and then come back. It'll let you see if you know what's going on. All right, so hopefully now you've tried the lesson check. Let's check our answers and see what we knew how to do. Okay, so if possible, make a conclusion from the given statements. What reasoning did you use? So if a figure is a three-sided polygon, then it is a triangle. So this is a conditional statement. This is a P implies Q statement. And then we have figure ABC is a three-sided polygon. That's not a conditional statement. However, this statement matches the hypothesis of our other conditional statement. So we have a P statement again. All right, so this looks like the law of detachment because our Q fell off. It got detached from it, okay, the second statement. So let's fix this to deduce our conclusion here. So first we want to know the P, the hypothesis from our conditional statement. So this is a figure is a three-sided polygon. Okay, and our conclusion is it is a triangle. All right, if we flip the page over, underline the correct words to complete each sentence. The second statement matches the hypothesis of the first statement. So flip back and look. So figure is three-sided polygon, that goes with the hypothesis. So figure ABC matches our hypothesis. Okay, I can use the law of detachment to state a conclusion here, and our conclusion would be figure ABC, which matches the hypothesis that is true, should also now match the conclusion that is true. And our conclusion was it is a triangle. There's our conclusion. So figure ABC is a triangle. And that's supposed to look like a triangle. Okay. All right. Lesson check part 2. Did you understand? All right. So what is the error in the reasoning below? So we have this. Birds that weigh more than 50 pounds cannot fly. A kiwi cannot fly. So a kiwi weighs more than 50 pounds. So right, birds that weigh more than 50 pounds cannot fly as a conditional statement. So we know they did an error in here. We got to find it. So this should be if a bird weighs more than 50 pounds, comma, then it cannot fly. All right, so I'm going to circle my hypothesis. A bird weighs more than 50 pounds. And then I'll circle my conclusion in blue. It cannot fly. Now, write the hypothesis of the conditional in exercise 21. So our hypothesis was the red one. A bird weighs more than 50 pounds. Okay. Underline the correct word to complete each sentence. So let's see. A kiwi cannot fly matches the conclusion of the conditional. The student incorrectly applied the law of detachment. So let's see what they did. They said P implies Q. That was a bird weighs more than 50 pounds here, and it can't fly. And then they said, hey, a bird can't fly. So this was the given facts. And given these facts, they tried to deduce P, the hypothesis. You cannot deduce the hypothesis from a conclusion. You can only deduce the conclusion from the hypothesis. So this does not match the law of detachment. So it don't work for us. Okay. Now both of the lesson checks were about the law of detachment. So please make sure you go back and look over the law of syllogism. Okay. All right. So we have following things you should be able to check off. What is the law of detachment? What is the law of syllogism? What is deductive reasoning and how is it different than inductive reasoning? And then what's a conditional statement for the 4th time in a row? Okay. All right. And then you should mark where you are. And if you cannot check those off, then you want to go back and watch the video. Or if you don't know the I get it and you're way down here, then you probably want to watch the video again. Okay. I'll see you in class next time.